I have the pleasure of introducing today David Reitzel, also known as Doc. He is truly one of our experts here at Black Rock Observatory, as I would say definitely one of our board members and one of our earliest members of our wonderful camp here on Playa. He has his Ph.D. in Astronomy and Astrophysics from UC Santa Cruz and currently works as an astronomer at the esteemed Griffith Observatory in Los Angeles. Today, Doc can talk about many things, but today I'm so excited that he's going to be giving a presentation on comets and how we can use observations to help uncover some secrets to these mysterious objects. Anything else I can cover for you?
No, thank you, Amy.
Awesome. Take it away, Doc. Can we have a big round of applause for him? Thank you.
Thank you for that very nice introduction. Indeed, it's wonderful to be out here on Playa. This is my 21st burn, so but I only started actually doing a little bit of science communication and whatnot with Black Rock Observatory in 2017, 18. I don't know. I'm losing track of that too with pandemic. Everybody's losing their minds. But I have to say I'm having more fun than ever working with Black Rock Observatory, and I feel very privileged to be able to bring you a talk like this. The talk is called Clues from Comets, and it actually comes from the 5th grade school program that I helped create for 5th graders. And it's an online program that kids can log into and watch. And I've taken those slides, and I'm going to tell you kind of the same story, but I'm not going to stick to quite the script that we have for it, because one, I don't know the script. I've trained my employees to know it, and I wrote it, but I don't remember everything. So I'm going to do my best to carry on and go through that. Here's the clicker. And, oh, we have to launch the talk, too. That would help. Next slide. Perfect. Well, this is easy. And hopefully the volume is up. And if not, we'll discover that. Nope. There we go. All right, so first of all, Clues from Comets, and I'm David Reitzel, Black Rock Observatory and Griffith Observatory. Well, it's okay-ish. If you saw something like that in the sky, I'm not sure we're seeing anything. Well, no, there's no audio on the slides. I'm just not seeing anything on the screens. Can you see it? Just I can't. Okay, perfect. Well, that works out well. So if you saw something like in the sky, would you be afraid if you saw this thing up there? Now, keep in mind, this is a comet. It's a little different than a meteor. Comets take a long time to travel across the sky, and they're in the same place, roughly, night to night, but it can have this sort of bright, fuzzy area and then a long tail coming off of it. And usually comets have two tails, one that's kind of straight and one that's kind of arcing in the sky and is a little fuzzier. Would any of you be a little scared if you saw something like that while you were out camping or you were out at Burning Man? Hell yeah. Because people back in the past, they were frightened by these things. They used to take them as harbingers of doom. They would think that instead of it being just a beautiful sight in the sky, they would say, oh no, is there going to be a famine? Is there going to be a war? Did we do something wrong? Have we angered the gods? Where did this thing come from? They didn't know what it was. So there's a lot of old artwork where you have disturbed people pointing up at it saying, oh no, what the hell is that? And quite frightened by it. So we would have to think about, well, what can we do to figure out if these really are bad news? And people back then had to figure out a way to sort of research this stuff and say, what can we do to learn whether comets are good or bad? How can we think about that? So luckily, throughout the ages, people kept records of when these were seen. And you could take a look and see, oh, it's up in the sky, and this one happened at a particular time, and they took down the date of it. So they were beginning to build a record of seeing these objects, and it was cultures throughout the whole Earth that were keeping these records. It wasn't just Western society, it was Eastern. Everybody saw them, everyone on Earth, so all cultures. And there's another comet there in the sky, and even this is the Chinese taking records of comets. And if you start to piece all of this together, you can learn some things about it. And now we'll see whether this works. So another beautiful artwork of comets. Now we'll see if this plays. I don't think we're getting any volume.
Explain how the planets
there
move
it is.
around the sun.
I will reset it.
Astronomer Ed.
So these videos, again, are from our 5th grade school program. So if they seem like, why are they talking to us like children? Because these are 10-year-olds that we talk to. So just be patient. But my wonderful co-content creator, Ella Ritz, who wants to come to Burning Man but couldn't make it this year, narrated these and created them, and I'm so proud of her work. I wanted to show it off to you all. So they're only a minute and a half long or so, or a minute.
The discovery of the law of gravitation allowed astronomers to explain how the planets move around the sun. Astronomer Edmund Halley in England was the first to apply these ideas to a comet, to take all those observations of comets long ago and comets he had observed, and then see if any comet acted like a planet orbiting the sun. He calculated the paths of several comets using the same laws of physics that worked for planets. He found that the movements of the comet he saw in 1682 were the same as a comet seen 76 years before and 76 years before that. They might have been the same comet just coming back again. That was his hypothesis, or prediction. If that were true, Halley's hypothesis could be tested, which is how science works. Halley predicted when the comet would come back, where it would appear in the sky, how it would move, and how long it would be visible. He didn't, however, live quite long enough to see it, but the comet did come back, just as he said. That answered the question. Comets are not connected to events on Earth. Their movements are controlled by gravity.
So exactly, the comet's movement is just reacting to gravity. And the planets have gravity. The sun is the primary source of gravity in our solar system, but they were not connected to events on Earth. If a military leader was planning a war, sure, that person could have looked up in the sky and said, there's the comet, let me go to war, but the comet didn't make that military leader want to have the war necessarily. They weren't created. Didn't bring a famine is not necessarily a bad sign. So the comet is a natural phenomena that is separate. So there's no connection between the appearance of a comet and bad things happen. It's just, it could be coincidence that you had a plague go through your city. It wasn't the comet's fault. Let's see here. Edmund Halley and other folks throughout time, keeping these records are what it made it possible. So again, observation and documentation is all part of science. And that's how we were able to understand what comets were and what they did. Some comets look a little different. Some of them are fat, some of them are skinny. Halley's Comet, of course, is a famous one named after him, and it's a periodic comet. It keeps coming back over and over again. But this is Miss Mitchell. Her comet, she was the first female American astronomer, and yes, indeed, so let's celebrate that. And she discovered a comet, and it was not one that was going to come back. It came in, was seen, and it was on what's known as a parabolic orbit. So it flew out of the solar system when it was on its way. But still, an important discovery by a woman astronomer. So I think it's important to point that out. Yeah, exactly. So now that we know that comets are a natural phenomena, but what are they made of? If we want to figure out what they're made of, we can look at something called a spectrograph and think about the periodic table of elements. This is a spectrograph at Griffith Observatory. You take the light from an object and you break it into a rainbow. And the different elements, the chemical elements within the comet's tail, within the coma, and in the comet itself, leave an imprint on that. Little dark lines or little bright lines if they're glowing. That you get both kinds, emission lines and absorption lines. And it tells you which of these elements in the periodic table are present in the comet. So I have another little video here to talk about that.
This is a collection of almost all of the atoms or elements that we find in the universe. 92 are found in nature. Gold and silver are used for jewelry, iron is used in steel, sodium is found in salt, and we breathe oxygen. Every element has a unique fingerprint. Whenever a comet is discovered, astronomers study it with a spectroscope to see those fingerprints and then learn the comet's ingredients. A spectroscope takes light and spreads it out into a rainbow. This spectroscope in Griffith Observatory's Amundsen Hall of the Sky captures light that comes from the sun. Atoms in the sun's atmosphere absorb light and make dark lines in the spectrum. The dark lines are the fingerprints that reveal what elements are in the sun. Astronomers use the same tool on comets. A comet spectrum looks different from a solar spectrum. Element fingerprints from a comet show up as bright lines. This is because the gases in a comet glow. By analyzing the light from comets, astronomers discovered they are composed of water ice, rock, dust, and other frozen compounds like ammonia and methane. Comets also have the essential elements for life. People need 25 elements to live, and we see them when this button is pushed. 6 of these elements are present within all life forms on Earth: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, or SNOPS for short. Comets contain SNOPS, the essential elements for life.
Yeah, we like to say that schnapps is essential for life on the playa as well. So just a little joke for the adults, of course. So now we know enough that we can make a comet. And that's what I want to try and do for you today, is to take some basic stuff, put it together, and make what's a comet in front of you. Asteroids, when they split up and chunks of rock fall down to Earth, if you have a chunk of rock just floating out in space, it's a meteoroid. If it's destined to fall to Earth. When it is falling through the atmosphere and you leave that glowing trail, you're seeing a meteor. And we've all seen meteors during meteor showers. If that rock falls to Earth and hits the ground and you pick it up, it's actually a meteorite. And we have a meteorite museum right there that you can go in and look at all sorts of meteorites that have fallen to the ground. But a comet, since it's an icy body, I can't take a piece of a comet and hold it up for you. So I'm going to make an analog for you right now. We're going to take some ingredients, put them together, and see if we can produce something that's a little bit like a comet. Nah, it's good. So first of all, we need something to hold the comet. So we have a bag of space. Now comets, one of the main ingredients in comets is water, and there's a little ice in here to bring down the temperature too. No, it's all right. It'll hang out here. All right, so I just added some water. That was some liquid water, although it was a sparkling water, but maybe comets are a little fizzy. So that's one of the main ingredients in comets is water. Now comets are also very dark, and they contain carbon. So I have some charcoal here, and we could use charcoal. We could use ground up diamonds if we found anybody that wanted to donate those here on Playa. But charcoal's cheaper, so I'm going to add some charcoal to this comet. Try not to moop. And I didn't grind it up very well, but that's all right. We're on Playa. It's like Playa time. Okay, so it's looking not great, but that's okay. Comets also contain sand and dust. We're all familiar with dust out here on the Playa. And the sand grains that are in comets are actually what create most shooting stars. When you have a periodic meteor shower, like the Perseid meteor shower we had last August, it happens every year about the same time, the Earth is actually traveling through the orbit of a comet, and that comet is leaving behind those grains of sand along that trail. So when those grains of sand come into our atmosphere, they make a streak or a meteor. Those burn up, they don't reach the ground, but those little grains of sand are important. Now for this comet, I'm going to just go down and scoop up some playa, because that seems like the best thing to do. All right, so that's looking pretty mucky. So there's our comet. What's wrong with it? Yeah, it's not frozen. Out in space, it turns out that liquids are a really difficult thing to have in space. You can have frozen water, you can have water vapor, but liquid water, you need to have something that has pressure to maintain it. The liquid will boil away and turn into a vapor if it's just up in space. So that's why we look on planetary bodies in general for life, because water is essential for life as well. So that's why we're thinking maybe Mars, maybe some of the moons that have liquid oceans in them around Jupiter and Saturn, which, by the way, you can see both of those planets over at our dome tonight when we're observing. We have Jupiter and Saturn as objects, and if you're lucky, you can see some of the moons orbiting, and those moons, while they have icy crusts, have oceans underneath that actually could contain life, because life needs energy and liquid water. So comets have a lot of the ingredients for life. And another ingredient they have that helps with life is vinegar. Okay, well, they don't have vinegar, and normally we use ammonia because they contain ammonia, but I figured out on Playa it's more appropriate to spray some vinegar in this because they have a lot of hydrocarbon compounds, things like, again, like ammonia and other gases. So I'm just going to use vinegar as a placeholder for those and give it a few squirts. All right, so now we're nearly there. Let's stir it up a little bit. Looking pretty good. But now the fun part. I'm going to turn off the microphone as soon as I tell you what I'm going to do. I am going to attempt to make some dry ice. And we're going to use the dry ice to freeze this comet. And if it doesn't work, well, then we're stuck with a juicy comet, which isn't too exciting. But we'll see. Let's see if we can make some dry ice. What I'm going to do is this is actually carbon dioxide. And comets do contain carbon dioxide in ice form. And this is liquid in here. But when you go from a high-pressure vessel and release it to lower pressure, it lowers the temperature. The temperature is going to go down, which will freeze the liquid CO2 that's in there. So I don't know if anybody else here on Playa has been taking little canisters and releasing those high pressure canisters to low pressure, but you might notice that they get cold when that happens. So if anybody's familiar with that, you'll know what I'm talking about. You can see in there the dry ice, the frozen carbon dioxide that was made doing that. So that did work, which is great. So now let's try and freeze our comet. So I probably should have the gloves on while I do this, but the Playa is a dangerous place. You've all read the back of your ticket, right? This is where we get to be the mad scientist, and it's so much fun. So that's looking pretty good already. Probably needs more carbon in it, but hey, I'll dump a little more in, try and make it a little blacker. It's freezing exceptionally well, I think. In fact, I might even need more water if anybody has some. Yeah, throw a little extra water in, yeah. That's good. Just enough to help me squeeze it together, so. So anyhow, we can try adding more water to it later if we want. But to finish up, let's see, what did I do with, there it is. So to finish up, you know, we started out talking about comets and whether we should be afraid of them. We learned that there was nothing to fear. But comets actually have something to teach us about ourselves as well. And we sent a mission called the Rosetta mission. We as humans, not we as in Griffith Observatory or Burning Man, but it was sent by ESA, the European Space Agency. And it went there to explore this comet, Churyumov-Gerasimenko. And they wanted to learn, how did it change from the time it was far from the sun, came close to the sun, heated up, grew a tail, outgassed, and then moved away from the sun again. They wanted to know what changes could we see, and also what was the comet made of, to analyze it up close and look at it. So we downloaded a bunch of images. Well, my assistant Ella did, or co-creator. She's not even really an assistant. Originally she was, but she was amazing, so I kind of promoted her. Anyhow, let's take a look at the video she made. She downloaded hundreds of images, raw images off the ESA site from this mission, stitched them together into a little movie, and I'm going to show that to you now, and you can hear the narration. It should. Problem is I didn't skip enough.
Thanks to detailed, accurate records and mathematics, we now know how comets move and why some come back. Spectroscopes gave us a recipe. We can now tell the story of comets. Earth formed at the same time as the Sun and all of the other planets. The inner parts of the solar system near Earth heated up and changed. The outermost parts, however, stayed cold and unchanged since the time the solar system formed. Comets formed far away from the Sun. The dust and ices stuck together. Then eventually, these grains were large enough to be drawn together by gravity, and they grew in size. There are hundreds of billions, even trillions of comets out where it is incredibly cold, but they are too faint and small to be seen. Because comets formed far from the Sun, and because most stayed there, they are frozen time capsules that can help tell us how the solar system formed. Like the planets in our solar system, comets are pulled by the Sun's gravity. They follow a predictable path around the Sun. This is the region where we find icy comets. They'll stay near the edge of the solar system, unnoticed and unchanged too, unless they happen to get nudged by the gravity of a passing object, and their path moves in toward the Sun. We learned that comets are made mostly of ices, with some dust and rock and organic compounds in the mix. Therefore, when a comet gets close enough to the Sun, it heats up, and the ice turns into gas and escapes into space. That creates a bright coma and a tail that can sometimes be observed from Earth. Comets that move too close to the Sun sublimate away completely into nothing. Others that survive the passage head away from the Sun, cool off, and lose their tails. Many comets circle back toward the Sun after many years. When they warm up again, they sprout another tail.
I jumped ahead a little bit, but let's take a look here. This is actually a photograph of Halley's Comet up close. That was a spacecraft we sent. We sent a spacecraft there and got a photo of it. And now this next video is the one about Churyumov-Gerasimenko. The last one, of course, was sort of summarizing everything I had talked about.
In 2014, the European Space Agency's Rosetta was sent into deep space on a mission to meet up with Comet 67P Churyumov-Gerasimenko. It was designed to observe the entire activity cycle of the comet over a period of 17 months. Rosetta met up with 67P Churyumov-Gerasimenko when it was still too far from the Sun to start outgassing. As the spacecraft approached the comet, It showed the comet looks a little like a rubber ducky, with two main parts connected by a narrow part. On arrival, we could see the comet is really a mountain-sized chunk of ice and rock about 4 kilometers across. That's about as big as downtown Los Angeles. Rosetta carried a smaller probe called Philae, which separated from Rosetta and landed on the comet before it began to heat up on its approach to the Sun. Philae took a farewell picture of Rosetta on its way down, and Rosetta photographed Philae as it fell toward the comet. These images of Philae include the comet in the background. The camera picked up the highly reflective Philae, but not the dark comet in the background. The comet is as dark as charcoal. To see the dark comet, Rosetta adjusted its camera to let in more light and captured multiple pictures of Philae drifting across the surface as it got closer to its projected landing spot. A lot had to go right to allow Philae to anchor to its landing spot on the surface. These are the last pictures Philae captured from above as it descended closer to the surface. Engineers designed screws, thrusters, and harpoons to anchor the probe to the comet. Unfortunately, Philae's landing equipment failed to activate and the probe bounced around in the super low gravity and eventually came to a stop, surrounded by towering cliffs and boulders of ice. Although the landing did not go exactly as planned, Philae managed to send a few pictures and important measurements from the surface before the batteries on board failed. Rosetta stayed with the comet during its journey around the Sun and watched the whole show as the ices heated up and sprayed into space. This was the very first time we had ever gotten a detailed look at how these jets of dust and gas shoot into space. After the comet moved away from the Sun, out where it is cold enough for the activity to cease, we observed changes that had occurred on the surface of the comet. Cliffs had collapsed, and immense boulders had been dislodged. As a final mission goal, space scientists guided Rosetta down to the comet's surface to end the mission with a crash. Images were taken on the way down, and instruments took final measurements. After 2 years of operations at the comet, Rosetta hit the comet and ended the mission.
So they left Moop on the comet. I know. It's NASA leaving and ESA leaving garbage everywhere they go. So it's there. Although if you think about it, once humans get there or other folks, those artifacts are going to be worth a lot of money. So it's kind of like it's really a treasure that's been left behind there. And we did learn a lot from that mission. It was an amazing mission that went there, that went very well overall. Poor Philae going down there, bouncing around with the harpoons not working, shooting down into the ice. But they had to try. They didn't know what the surface of the comet would be like. So it was a first attempt to make that happen. But anyway, we started talking about being worried about comets and not knowing what they were. Could they be bad for Earth? And it turns out that we learn a lot about ourselves. It turns out comets probably brought about 30% of the water to Earth. The comets running into Earth brought a lot of the water. They brought the organic compounds that we need for life. They contain a lot of the ingredients that are needed for life. So in a way, instead of being afraid of them, it turned out that we could learn from them. And that's kind of a lesson that we all learn here on the playa as well as we go out and experience what's there. So you don't need to be afraid. Look up and experience what's there and enjoy. So thank you so much. I'm happy. Well, thank you. Yeah. Yeah, I'm happy to take some questions. I don't have too long because my time is up, but a couple of questions. They haven't looked for DNA, although that is something that would be great to do. It turns out on a very large comet, it might have been liquid in the center long enough before it froze, just due to the heat of it coming together, to have life be able to kick off in there. We just don't know for sure. But the comets... No, the comets form in space on their own. out there. In fact, you could see Churyumov-Gerasimenko, that duck-like shape. It was probably two comets that merged together to form a bigger one. Yeah, Will? We haven't carbon dated one, no. So I don't know, but they're ancient things. They come from the very outer solar system, so they were probably some of the first things to be formed out there and freeze. Yeah, it can. Comets don't always outgas in equally in all directions. Where the sunlight is hitting, they'll start outgassing, so it can change the spin, it can change the orbit a little bit as well. So a comet that's a periodic comet and is no danger of hitting Earth, it could evolve into something that would perhaps be dangerous for Earth. So we do watch them, we pay attention to them. One comes by about every 10 to 20 years that's a big one in the sky. You know, I just don't know. The question was, is the Dryas impact, is there evidence to believe that? And I think there was a moment, I think, of an extinction. I don't know a lot about it, but I believe it's a time where there was a large extinction on Earth, and whether it was a comet that impacted it, it wouldn't necessarily leave a crater. If it came in and airbursted, it still might do things like light forests on fire with the energy it brought. But I don't know enough about it to say one way or the other, but from my memory way back there, I think it's plausible. I think it is possible. It's not ruled out. Yeah, why is one tail straight, one tail curved? Well, one tail is made up of sand and dust, and that tail has a little more momentum and energy, and it tends to keep along the same track as the comet. The other tail is made of ions and responds more strongly to the solar wind. The solar wind is made of charged particles, so the short, stubby, straight tail tends to point nearly straight away from the sun, at least the direction of the solar wind coming from, whereas the other tail tends to arc away and follow a little bit more of the path that the comet is taking. No, we found all the same elements on comets that we find on Earth, and we've produced elements in labs here on Earth that are very short-lived, but our knowledge of chemistry and physics, we think we pretty well know what all elements are going to be out there that are stable. So our science of the periodic table is very well understood. Now, our understanding of how molecules work and more complex things, we're still learning a lot about that. So there could be molecules or combination of molecules that happen in certain patterns or with certain combinations that we don't know about. So there's still room to have our dreams and fantasies, and we're learning a lot still, of course. Any other question? Yeah. Well, if it was nudged in with enough energy, it'll come in, swing around the sun, and then actually float away from our solar system to just go into interstellar space. So, or possibly it just is just strong enough that it's not going to come back for 100 million years, and then it could come back around and come in. But that calculation of, is it ever going to come back or is it completely going to leave, that's a very fine line between those. But all we know is it's not coming back anytime in our lifetime or in the next thousands of years. So, yeah. We actually have seen a comet, an interstellar comet, one that came from another star. One has flown through, and it was traveling at such a speed, we knew it didn't come from our own reservoir of comets, the Oort cloud or the Kuiper belt, that it literally came from another star. So we know that some do leave their solar system. One flew through our own. Yeah. Well, Earth very early on was a hot molten place. And we're learning now that some of the water was trapped within those rocks and somehow all didn't steam away. A decade ago, most people would have thought Earth would have lost almost all its water at that point. And we were thinking, how did we gain our water? Well, impacts were very important. You look at the moon through our telescope, you can see that it's cratered, and there's been lots of impacts on it. Some of those impacts were asteroids that were watery, wet asteroids that had water in them, locked up and frozen stuff. And some of those were comets that were mostly ices. So when we look at the type of water, so sort of the number of neutrons that are in the water and science stuff about it, we can tell that the comets have a slightly different kind of water depending on where they come from. And when we look at the water here on Earth and we look at that, we think, well, it's plausible that about 30% came from comets. And the rest of it was either here already or came from these wet, watery asteroids, even though it's frozen in the asteroid, but still. So yeah, it's a great question though. Do I have time for one more? No, need to move on, but I'm happy to take questions. I'll step aside. Anybody that has questions, I'm happy to answer them. Thank you so much, everybody.